This video will explain how to monitor the resource usage of your application with AQtime. AQtime includes this special resource profiler that lets you trace how a Windows application consumes resources. This tracks how the application allocates and deallocates resources such as fonts, bitmaps, graphic components, registry entries, and so forth. It also tracks errors that occur when calling Windows API functions that are specifically dealing with resources. So let me show you how you can use this profiler to analyze your application. In today's demo, I'm going to use this sample application that ships with AQtime, and this application allocates GDI and COM resources during its execution. We're going to profile this application with AQtime to find out if the application releases the allocated resources properly. Okay, I've already created a project here with AQtime, and the next thing I want to do is add my application to my project. So I'm just going to right click on the modules node here, say add module, and then select the executable that I want to profile. Okay, we're going to read some debug information. All right, now we make sure that the resource profiler has been selected from the list of available profilers, and then we'll click the Run button. Now, the Run button is going to bring up this Run Settings dialog. And in this dialog, you can configure settings for the coming profiler run. So you can choose the categories of resource management functions that should be traced during the profiling. In the given run today, we're only going to choose to trace resources of the GDI and user resources type. So that's the box I'm going to leave checked. I'm going to leave all the other ones unchecked. Now this collect stack information setting specifies what information the profiler will save to call stacks when the application allocates resources. And I'm going to use by lines in today's setting here. This means that the call stack entries will include information about routines as well as information about the source line numbers. Alright, so now we're ready to get going, so I'm going to click the Run button. AQtime has launched my application, and I'm going to click the GDI leak button. So now the application will call some functions that cause an intentional GDI link, and now I'm going to close the application down. And AQtime is going to generate some results and render them here on screen. As you can see, AQtime organizes profiling results into three categories: classes data, objects, and errors. The classes data provides information about resource types whose instances were allocated from the profiled module during the run. These profiling results include the total and current number of resource instances, their size, etc. And if we look over here, we can see that we have an instance of an object whose live count is not 0. This means that a resource of this DC type that you see right here was still in existence in memory at the moment in time when our results were generated. That is, when the application closed, this object was still in memory. So to obtain information about this resource, I'm going to select the objects category here in the report panel, and here we can see that we have a device context, or DC, resource living in memory at the moment of results generation. So the number displayed next to the resource name, in this case 108, indicates that this is the 108th instance that was allocated during the application run. So let's find the function that allocated this resource. So to do this, I'll click on the DC resource here in the report panel, and then I'm going to come down here and click on the details pane. Now this details pane displays the sequence of function calls that led to that resource allocation. For each routine in the call stack, AQtime shows the module that holds the routine, the name of the source file that contains the routine's code, and the line number at which the routine's code starts in the source file. Now the topmost routine in the stack is the Windows API function that called the resource. As you can see, this example is from the user32 library. The next function in the stack is the on resource call right here, and then this is the function that called the getDC API function. So to view the source code of this routine, I'm just going to double click on it here, and AQtime brings up the editor panel and positions the cursor on the corresponding line in the source code. Now as you can see, the onResource function that we're working with here allocates the screen context but does not release it, and this is what's causing a resource leak. So what I'm going to do to fix this bug is going to add some code that will release that device context resource. Okay, so I've just opened up Visual Studio and I've browsed out to the appropriate source code file, and so what I'm going to do is make some tweaks to this routine here, the onResource routine, in order to improve performance. So this routine is the one that's allocating that GDI resource, and we can see that this line right here is the call to the getDC function that obtains a reference to the device context. Now, as you may know from the Windows programmer documentation, every call to the getDC function must have a corresponding call to the releaseDC function in order to free the device context resource that gets allocated by that getDC. So to eliminate the leak, I'm going to add a releaseDC call to the end of this method. So let's go ahead and put that in here. Okay, now I'm going to save the changes, and I will rebuild my solution. Okay, so now let's switch back to AQtime, and we're going to reprofile the application to see if that corrected our leak here. So I'm going to bring the application back up. AQtime is going to automatically read in the updated code. We'll generate that leak again. Click Close. AQtime is going to generate our results. Now I'm going to look at the classes data here, and you'll notice that our live count for all the information inside our classes data is now 0. That's great. That means there are no objects left in memory after the application was closed. And we can see that further here when we double click on the objects node, we see that there's no entries here in the module palette. So that means that there were no objects left in memory after the application is closed. So we have corrected that memory leak. Now, as I said before, in addition to information about the allocated resources, the resource profiler will also report what errors occurred in resource management functions during the application run. To view information about those errors, just double-click on the errors category here in the profiling results. And in the report panel, you can see a description of the error that occurred. You can also see the module that the error occurred in. And finally, you also get a reference to the Microsoft documentation that describes information about that error, so you can just go out and get more information that way. When you select an individual error in the report panel, the details pane will display a sequence of function calls that called the error. To view the source code of a desired routine, just double-click on the routine here in the details pane, and the AQtime will bring up the editor panel and position the cursor to the beginning of that routine's code. So as you can see, using the report, details, and editor panels, you can quickly find out what resource-related functions failed and determine why. This concludes our video on resource profiling. We hope you found it helpful. If you have any questions, please don't hesitate to contact us at our website as you see on our screen. We wish you luck and hope you enjoy profiling your applications with AQtime.